And thank you for the warm welcome, Kate. So before starting on to the presentation, I want to bring something up from my talk summary, wherein I mentioned that I'll be presenting a new perspective to AI security. Well, it will be new and familiar both. Confused? Let me explain. When we talk about AI as a service, sorry, um, sorry. When we talk about AI as a service, the threat, the attack surface expands just beyond the uh, models and the prompts. And in general, today we have just talked about the models and prompts and attacks on it. But today I'll be showing you that there are other things that also matters, which is the configurations around your AI application, the AI libraries that you use, the cloud misconfiguration that you should not do, and the security of your MLOps pipeline. That is also a major issue here. Yeah, so agenda goes like this. So first I'll be talking about what is AI as a service and why does it matter. And then I'll be talking about different incidents and reports to establish the urgency of the attacks on AI. And then I'll be talking about different threat vectors and targets when it comes to AI as a service. And then I'll be demonstrating an attack scenario involving AWS AI as a service and MLOps pipeline connected to it. And then I'll be jumping onto the solutions, wherein I'll be mentioning different threat monitoring techniques when it comes to AWS AI pipelines. And then I'll be talking about different best practices to prevent different attacks in AWS AI as a service. Well, um, as the name suggests, AI as a service means anything, any AI capabilities that you see on cloud is AI as a service. And these capabilities involve like foundational models, APIs, data training, model tuning frameworks, etc. And there are a lot of CSPs already in the market, like AWS, Google Cloud, Microsoft Azure, etc. And the most famous one you can see is Azure AI Services, and then comes the Amazon SageMaker, and then Azure OpenAI. And then comes the Azure ML Studio, Vertex AI, AI Platform, and a lot of other things. One AI services that I haven't mentioned here is the Bedrock, which I'll be talking about later in my presentation alongside the SageMaker. Yeah, then why AI as a service is taking popularity? Well, it cuts a lot of your infrastructure and expertise costs. You just have to code your way through and deploy it as an application on AI as a service. Again, AI requires a lot of compute. So so AI as a service provides you a lot of pay-as-you-go pricing, which it's very beneficial for this. And it provides, as I said, it also provides a lot of pre-built models and frameworks that you can directly use and deploy your AI application. And you can kind of build an AI application ecosystem around this with different other cloud services, because it's very much integrable with the AI service, AI as a service. And last but not the least, the CSPs that have this AI as a service, they kind of have a lot of latest AI innovations already. So yeah, as you can see from the bar graph, AI as a service is actually growing. And in a couple of years down the line, you'll see massive growth in market size when it comes to AI as a service. And if you see from the current deployment status of AI, more than 50% are already deployed on public, and few are in private. Public means AI as a service, and few are already in private, and few are like hybrid. Well, let's deep dive into the incidents and reports to establish the urgency of AI security here. So because of the rise of AI and the AI as a service, you can see rise in the cyber attacks. 30% of these cyber attacks mostly are training data poisoning, model theft, adversarial samples. And it's not something in distant future. 93% of security leaders expect to encounter daily AI attacks by 2025. As I mentioned before, 30% of AI cyber attacks involve intrinsic AI attacks like training data poisoning and all. Rest of them actually involves exposures and misconfigurations. So one of the misconfigurations that is very famous is 82% of organizations using Amazon SageMaker and they have at least one internet-exposed notebook. So I want the audience to note this point because I'll be taking up this point later in my presentation. And then comes so AI requires data, and when you're using AI as a service, so you'll be using a lot of cloud storage. And that is also a big problem. Cloud storage misconfigurations. Almost 21% have an internet exposed S3 bucket, with 54% storing PII. One more concern that I feel is important is the increasing CVEs in the AI systems and libraries. So as set by JFrog, almost 20 plus AI-related CVEs are already there. It's like, of course, fixed, affecting across all the ML vendors. And I was just reading about one more library that is TensorFlow. It had a whooping 426 CVEs in just past few years. So this can be a rising concern, especially for your public-facing AI application. Yeah, and because of all these, organizations are already stressed out. They are unable to find proper adequate security tools for their ML systems. And 1 in 4 organizations have already banned Gen AI due to privacy and security risks. And last but not the least, 66% of cybersecurity professionals have reported increased stress due to the complex threat landscape of AI. So this is the incident timeline of the major attacks that have happened on the cloud infrastructure. And this is like the timeline from 2020 to 2024, majorly dealing with the AIaaS threats and the AI systems threats. I'll not be deep diving into each attack. You can refer it later from the PPT that will be shared to you. Yeah, let's deep dive into the attack vectors and targets when it comes to AI as a service and AI in general. So poor coding practices is something that is a major concern, as told by Chris. So developers over-rely on code generation models, and they just copy-paste those codes, and this can give a lot of vulnerabilities, introduce a lot of vulnerabilities in your public-facing AI application. Misconfiguration is also something a big concern. Misconfiguration is like opening your front door for the robbers to come in and rob everything. Vulnerabilities in AI libraries. This is also a common issue, as I already said, which can impart a lot of vulnerabilities in your public-facing AI application. Unverified third-party dependency. This is also a big issue, especially with the developers and data scientists. Developers use a lot of third-party extensions, and that could inculcate a lot of malicious code into your MLOps pipeline and public-facing application. Data scientists use a lot of data sets that do third-party, which can actually inculcate a lot of biases into your MLOps pipeline and your application. So we have chosen a target infrastructure as an MLOps pipeline in which the developers use SageMaker Notebook in their dev AWS account. And in prod AWS account, you have Bedrock, wherein we have deployed a chat application. So we are using Amazon Bedrock here. So let me explain that with a diagram. So this is the dev AWS account. So we have a lot of SageMaker Notebook here. And one of the SageMaker Notebook is misconfigured. So as I mentioned before, 82% of organizations already have one notebook exposed publicly. So this is a major concern, and I'll be telling you how it can impact your MLOps pipeline in just a second. Also, this is the prod AWS account, wherein we are using Amazon Bedrock, and we have 2 models here. One is the code generation custom model that generates Python-based SQL queries to get a lot of customer data. For example, if I want to query something like what's my Amazon status, like the order status. So it will fetch that using Python-based SQL query that will be executed by the Lambda. Then comes the conversational model agent, which is basically just for the chat application. And then there are a lot of other things like the RAG architecture using knowledge base and S3. And okay, yeah, there's something called guardrail in Bedrock, wherein you can actually configure those. It's like a firewall for your prompt. You can configure, like, for example, For certain words, you can configure guardrail that, yeah, I need to block these prompts if these words occur in the prompt with certain kind of block messages. So we have two guardrails already active. It's for the code generation custom model, and the second one is the conversation model agent. Yeah, so there's a web application that basically is chat application, and that uses Bedrock in the backend via the API gateway. And yeah, one more thing I didn't explain here is, yeah, the dev AWS account has a GitHub connected to them. So they basically churn out different versions of models, which is pushed to the GitHub and is pulled in to the production account. It's like a versioning system. And one of the admins or dev have a cross-account role, basically cross-account access to the guardrail. So yeah, this was the target infrastructure. Yeah, so before starting on to the attack, I want to put some disclaimers here. It's just an internal purple teaming exercise to demonstrate different poor coding practices and native feature abuse, misconfigurations, unverified third-party dependencies. No way I'm mentioning anything about AWS Bedrock or SageMaker. It doesn't have any weakness or vulnerabilities. Yeah, let's go over the attack. So as I said before, one of the developers misconfigured the notebook. Now, one of the misconfigurations that is a big thing is the SageMaker notebook was actually accessible over the internet. So, and the developer used an unverified third-party extension. So what happened is the attacker had a GitHub account, and he hosted an extension, a SageMaker plugin that was malicious. And that developer downloaded that SageMaker plugin, and because of which, attacker actually took over the notebook instance. So let me show how it looks like. So if you see the first image, it's the image from the developer's terminal. So he's basically installing SageMaker plugin here. And then the second image is the attacker's image, the terminal, wherein as soon as the developer installs the SageMaker plugin, the attacker is getting reverse TCP on that SageMaker notebook. And this is also specified in the notebook Jupyter Lab, which is installed, that third-party dependencies can be risky. Use it at your own risk. Yeah, so after attacker takes over the SageMaker notebook, so what happened in the misconfiguration is, so it's a very common thing, like we do click, 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 and we install anything with all the default things, right? Default role, default, like what exactly happened is default VPC was, so no VPC was assigned to it, because of which there's no firewall for the notebook. And second, there was a default role that AWS assigned, if you don't assign a role or permission by yourself explicitly. So that permission, that role has a lot of permissions, and I'll let you know how. So one of the permission that is SageMaker node. So the attacker will be having a one more permission to deploy one more notebook for himself. That will be the permission of that. And he can also attach a role to it. So what attacker does here, he actually escalates, oh, just a sec, yeah. He actually escalates his privilege by attaching one more role to the newly created notebook. And these all permissions were already there in the default role. So yeah, so just one small mistake by developer actually led to the whole compromise the dev AWS account, because attacker now has his own notebook with admin access to the dev AWS account. And now what he can do is he can poison the training data. He can blend in with the developers. Well, I won't go on the path of poisoning training data and all. So yeah. Next, so attacker is really ambitious. He wanted to jump into the prod AWS account. So what he did is he abused the cross-account role from the dev environment to the prod environment. So this is one of the common misconfigurations wherein people think that if I put an MFA and authentication in one AWS account, if I have multiple AWS account and there is an MFA in one AWS account and there is an MFA in another AWS account. but there is no MFA or authentication in the cross-account role. That is the biggest risk, because if one AWS account gets compromised, the other one would also be compromised. So, which is what is happening here. So now, attacker has got access to the guardrail. Well, what he can do with that? The maximum thing he can do is switch off the guardrail and try to prompt inject from the web application. That'll take a lot of time, and security guys would know that someone has switched off the guardrail. So what he does, he poisons the guardrail in such a way that for every prompt that contains how or what in it, that prompt would be blocked. It won't be allowed to go further to the model. And there would be a block message going to the user saying, okay, for this question, refer this link. And that link would be malicious. An attacker would trust the AI application, right? Like, it's your AI application, and they don't know what's happening in the backend, so they just click it, and they'll be compromised. And how it looks like, I can just explain that with a video. Yeah. Yeah, so as you can see, the top terminal is the attacker's terminal, and the bottom one is the application. So this is just a normal application. You can see it's working fine, chat application. Yeah, now what attacker will do is he'll poison the guardrail in such a way that for any, so if you can see word policy config, any prompt that will be having how and what, which is very common in a prompt, there will be a block message going with a malicious link, and you can see how it looks like here. So if I type in how is a cookie made, so it will be like, for more information, refer our detailed guide, and that guide would be a malicious PDF. Yeah, so basically what attacker did is, so the service that was used to protect the AI model, he actually turned the table around, and he used that protection service to attack the AI infrastructure. Yeah, so attacker was really ambitious. Like, he wanted to get hands on to the sensitive data. He has already compromised the user. So if you see, so one of the guardrail is already compromised, which was for the conversational model agent. Now, he wanted to get access to the sensitive data. For that, what he can do is he can inject code also, right, in the block message. Like, if you can inject link, you can inject code. So what he exactly does? So as I mentioned before, the code generation model generates a Python-based SQL query. This goes downstream to the Lambda, which is executed, and it fetches using the Python SQL query, it fetches the data from the customer, like the S3 and the DynamoDB. So what he'll do is he'll poison the guardrail in such a way, the same way that we did see now, and put a code in that to get the role credential for the Lambda. So let me demonstrate how it looks like. Yeah, it's the same thing. The upper terminal is the attacker's terminal, and this is the chat application. So just imagine, like, if I'm querying something like, what's the status of my Amazon order? And in the backend, it is sent to the, so the Lambda sends this query to the code generation model. But what happens now is attacker poisons the guardrail in such a way that the query, the request will not go to the model now. It'll be blocked, and the code will come to the Lambda and get executed. Yeah. So for example, what is the status of my Amazon order? So he has poisoned the model, the guardrail. Yeah, and he got the access key and secret key for the Lambda. So, I mean, Lambda had the business logic for the whole Bedrock. So if he has access to the Lambda role credentials, he has access to every single thing in Bedrock. So what he does, he enumerates the permissions, and he poisons the RAG architecture by replacing the existing S3 bucket with his own S3 bucket. And finally, he gets the access to the sensitive data. Well, we've talked about the problems now. We can talk about the solutions. So one of the native AWS services that you can use to monitor these kind of threats and the attacks going on is CloudTrail. So CloudTrail logging basically provides you a basic overview of what is happening in AWS, your AWS account. And this is how the CloudTrail log looks like. It basically tells you who did what, when, and where. So this is the log from the attack scenario itself. Someone is creating the notebook instance with the SageMaker notebook name, and then direct internet access was enabled. So here we have two aspects. Like one is ongoing misconfiguration happening by a developer, and the second is the ongoing attack happening by the attacker. So both of these would be detected by CloudTrail. So it's very difficult to go over each CloudTrail logs. There are a lot of CloudTrail logs generated per day. So you can use CloudWatch detections, wherein you can actually create metrics and alarms. Metric is like a signature for that log, and the alarms is something like, what do you want to do with those triggers? So let me explain how it looks like. So you see the first image is the metric filter, which has like event name equal to create notebook instance, and request parameters direct internet access enabled. So as soon as this triggers, you can do anything with the alarms. Like you want to send those alarms to your email endpoint, or you want to take some actions using Lambda. Yeah, so this is how it looks like on the Outlook. So someone had created a notebook deployed with direct internet access in my AWS account. Yeah, so let's go over the proactive strategies when it comes to securing AWS AI pipelines. Well, implement the principle of least privilege. Don't be that guy. That guy, I mean, the developer. Always assign roles and permissions that are necessary for your AI compute and for yourself. And then you have to leverage AWS security features like AWS KMS and CMKs for data encryption at rest. Like, for example, if you're keeping everything in S3 data encrypted, and also enable VPC isolation for any AI compute that you have in your dev or AWS account, especially dev account. And then configure Bedrock guardrails properly, like maintain a versioning system, see who is updating the guardrail with what configuration. Also follow secure ML coding practices, sanitize any model outputs and inputs that, and prevent any sensitive data leaks. Follow proper versioning control for your code, and also see and vet properly the third-party libraries. Also use sandboxes. So as I said before, developers over-rely on the code generation model. So use sandboxes to first verify if that code is secure, and then put it in production. Well, monitoring is very, very important, as I said, with the two aspects. Checking if there is an ongoing misconfiguration happening, and second, if there is an attack happening. And last but not the least, put explainable AI somewhere in your AI infrastructure, which will detect any kind of model tampering, adversarial manipulation, or detect any kind of bias in your application. Yeah, I think that was it. And if you want to read more about it, there's a blog that mentions everything that I've already explained, with some bonus content on how do we further monitor the whole attack chain. And you can connect with me on the LinkedIn for like any doubts that you have. Thank you.